Um, Thank you, Peter, for the intro. Yeah, my name is Feng Chen, and I go by Chen. So actually, I would suggest to make this a bit more interactive since we don't have that many people in this meeting. So feel free to unmute yourself and ask questions whenever you have them. I think that will be make this talk more interesting instead of listen to my lecture for 20 minutes in like a Saturday evening. That doesn't sound like fun. So let me share my screen. Uh, okay. Can you see my screen now?
Yep, it's transmitting perfectly fine.
Okay, cool. Because I cannot see you. Let me see. Can I? Yeah, I can actually. Yeah, because I cannot see you while presenting, I would suggest again, if you have questions, either type in the chat or just unmute yourself. Uh, Otherwise, I won't be able to see the interaction. Okay. So yeah, so the talk I'm giving a very rough sort of overview of my research is about embodied spatial intelligence. It is a term that we coined that combines two very popular terms lately, embodied AI and spatial intelligence. This is a term I used to summarize my research in the past, I think, over 10 years. Um, so before talking about the research, I think um, I would like to very use this opportunity to very briefly introduce you NYU's new Center for Robotics and Embodied Intelligence, or CREO. The CREO Center is launched last year, officially launched, and we're growing rapidly. It is a shared space located mainly at 370 J Street, the Brooklyn campus of NYU. As you can see, this is our seating and experimenting space. This is the rendering. The rendering looks almost exactly the same as what we have right now in the space. And in the space, we have all kinds of robots. We have robo-dogs, quadruped, and humanoid robots and fixed robotic arms. Um, at Creo, we do fundamental research with a bunch of professors at NYU and over 70 PhD students and postdoc researchers. So collectively, we have close to 100 people in the center. So so together with me and Professor Ludovic Righetti, and we co-direct the center. And then we have various experts at different aspects of robotics and embodied AI. So we work on different things like learning, perception, control, and planning. These are the algorithmic foundations for robotics. In terms of the problem domain the application domains that we focus with these robotics technologies, it ranges from deep space to deep water, right? Underwater robots. We also work on infrastructure maintenance and manufacturing with robotics and autonomous systems. We also work on human-robot interactions, assistive technologies that use benefits from robotics for socially beneficial applications with humans together. Um, my lab, AI Force Lab, is one of the research group at the Creo Center. So in my lab, we our big picture or the grand challenge that we want to tackle is develop to develop the novel algorithms and systems for intelligent agents. So these agents can accurately understand and efficiently interact with materials and humans in dynamic and unstructured environments. And in order to do this, we have to build a multidisciplinary team, and we have to adopt the use-inspired research methodology. So our students are coming from different backgrounds, different majors. I think this might be related to some of the questions that you have today, and I'll be happy to discuss with you more about it regarding what kind of major or focus you want to have in your future undergrad years. The user-inspired research methodology is something that sits between pure theoretical research versus pure applied research. So the idea is we start from some real world pain points, right? The real world problems or issues that needs to be addressed, and we study them carefully, and then we abstract the theoretical problems out of it, and then we try to tackle those theoretical challenges. Once we make any progress there, we apply them back to the original problem domain or similar problem domains. So that's what I call as user-inspired research, because the whole research is inspired by future actual usage. Okay, so this may be different than the pure theoretical research like mathematics or physics. For those, you're just driven by your scientific curiosity. You don't really care about that much about what the real application is. For us, we care about real application, but we don't want to be limited by the one or two problems itself. So we're not doing applied research. In order to do this, my team have expertise in both robotics and AI. More specifically, if you know these terms, computer vision, robot perception, machine learning, more specifically like localization, mapping, and 3D perception and 3D learning. In engineering, we work on construction robotics, autonomous systems in smart cities, such as connected and autonomous vehicles, delivery bots, so on and so forth. Okay. So the talk I'm giving today is called Embodied Spatial Intelligence. What this really means in layman's term is that we're interested in how we understand and interact with space through physical actions. So here we means not only the researchers or the scholars, but really we want different kinds of agents to be able to understand and interact with space. These agents typically are physical agents, meaning they have physical embodiments. We're less interested in agents that are purely virtual. So from this, you can know that we actually work less on the concept of metaverse because or virtual reality only. Besides these, we're not only interested in understanding this from the scientific aspect, we're also very interested in engineering those capabilities in machines. So here, these images are demonstrating some of the examples, like delivery bots, self-driving cars. These are wonderful examples that requires embodied spatial intelligence. And by the way, embodied spatial intelligence is not just they do not just exist in machines. In nature, we see them in different kinds of animals, even as simple as ants. Right? So collectively, they actually demonstrate very strong intelligent behaviors, as shown in this PNAS paper 2 years ago, where they show that to solve these kind of object transport tasks, that you need to really rearrange this object from this side to that side of the room. And to do that, you really need to go through a complex like planning process. And they show that a group of human is not necessarily more intelligent than a group of ants in this specific task, which is very interesting and inspiring. So besides this delivery cars, delivery robots and self-driving cars, people are using this, are trying to deploy this in other applications such as autonomous, like construction vehicles and machineries. Here is the work done in ETH Zurich in Europe, that they have a autonomous excavator or crane that does this kind of like huge dry like a stone dry stacking to build structures. Okay, and of course the Boston Dynamics company, I think many of you might have heard of it, and they are actively using these for like very complex factories or construction sites. And this is also one of their latest demonstrations that they developed this humanoid robot to perform some repetitive tasks in a manufacturing site. All right, so there are many, many different aspects that we can talk about regarding embodied intelligence or spatial intelligence. I summarize my group's research related to spatial and embodied spatial intelligence as the following four words, or the four M's. The first is mapping, second is moving, third is making, and finally is mingling. So we can go through this one by one, and I will try to fly through these using the following four slides. In those slides, I show some animations and images to hopefully give you some interesting idea regarding what we're doing there. So feel free to interrupt me if you want me to talk more about those animations. Otherwise, I will just fly through those. Okay. So mapping is the first M, and that is really about how to teach our robots to represent the world surrounding these robots. And in robotics term, we call this mapping, building maps of the surrounding environments. And we need to build those maps from typically what we call as egocentric observations, such as cameras or LiDARs, and things like that. Okay, and we want to use these egocentric observations to represent the observed environment. And these representations sometimes can be metric, meaning you can measure the distance and angle precisely in those representations. But some of those representations are topological, as a graph. If you have learned those concepts, you would know the difference. In those topological representations, we typically do not have accurate metric information such as distance or angle, but you have good description of the neighboring information, which entity is the neighbor of which other entities. Okay, and we care about. Go
I want to
ahead.
interrupt, sorry, quickly.
Mhm.
I know a lot of the members in my club are very interested in UAVs and drones, maybe
Mhm.
even commercial drone piloting, as I do sometimes. So I want to talk quickly about LiDAR and photogrammetry or camera-based mapping. So this is
Cool.
actually a really like highly growing field,
Mhm.
in how the way drones are going to be used in the future.
Mhm.
It's really a very active sector, and I think if you guys are interested in this kind of mapping, like Professor Feng is talking about now, you
Mhm.
really should kind of look into this kind of stuff. It's really, really interesting. Drones right now, they can bring mapping to like very, unreachable places. They can carry LiDAR sensors, camera like photogrammetry is becoming super, super accurate now with the high resolution cameras people are now putting on drones. So I think that's just very interesting and something worth looking into. Sorry.
Mhm. That's a good point. Right. So yeah, we do mapping here. This is for self-driving, and here we did a mapping process that is fully autonomous without any human attendance, and this is running at city scale using LiDAR sensors installed on self-driving cars. So in mapping, you care about not only geometry, right? You of course you need to know where things are, how far they are from the car, but also you want to know what they are, right? Um, Things that are really safety critical, you want to make sure you have good understanding of those. So we call these as parsing. You need to parse the semantic meaning of the scene. But mapping is more about parsing. It's also about reasoning. Given a bunch of images, especially if this is not done on the road on a like self-driving scene, but in an indoor such as household robotics. Let's say these robots observe a set of different images at different locations. How do they know the relative spatial relationship between those images? Think about your last experience of traveling. You may need to reserve hotels or Airbnb. And by looking just at a like 5 or 10 images sparsely located in that environment, you can certain people is able to understand the spatial layout of the room without continuous video-like observations. How can we enable a robot to have such kind of capabilities? All these problems we're interested in solving in the mapping direction. So moving on to this moving. Moving is about navigation. How do we decide where to go? And typically, we need to localize ourselves, right? Localize yourself on a Google map or some kind of like floor plan if it's indoor. And after you have good localization, you also need to make decisions. Where do you go, right? Where do you make a left turn or right turn? Do you move forward? Do you go upstairs or downstairs? So all these are related to moving or navigation. And here are some of our work previously. Actually, last year, we did one of the state-of-the-art image-based localization algorithm that you give an image to this algorithm, it will tell you like where you are precisely with only centimeter level like error and also a couple degree of rotation error. So this is actually much better than the GPS you can have, the GPS-based localization you can have on your cell phone. Okay? And people typically use this in self-driving because you need more accurate than the GPS signal alone. We also do things like teaching robo-dogs to navigate in the city of New York, right? They have all kinds of challenges, all kind of temporary structures, change of the environment. And our idea was to learn from thousands of hours of web scale videos. And that gives the robots ideas, a good prior on how to navigate in this urban environment. We also do things like indoor navigation as well, as depicted in this top corner animation. So besides mapping and moving, we are really interested in making changes or building structures in the physical world. If you think about currently what's already happening, or actually probably within 5 years, self-driving cars is going to be everywhere and delivery bots is going to be almost everywhere. But those things are just taking a person from place A to place B. And these problems you can think about like almost going to be solved, right? It's almost going to be solved. They're not completely solved, but almost going to be solved. But the next big challenge is about making. How can a robot make changes so that the space surrounding the robot is changed from configuration A to configuration B? In order to do this, you first need to navigate the robot in this environment, and this environment is changing, and you need to change the environment accordingly. So you have both the mapping and moving, and then the manipulation. All these challenge mixed together. Okay. So I usually use this WALL-E as my favorite example to explain what I mean by this, right? So if you watch that movie, you will see this little mobile robot can do very excellent work on changing the environment according to the instruction given to himself. Right now, our robots cannot do this yet, right? So this is still a very challenging task. But if you look at the nature, right, we have all kinds of animal architects. And using termite as an example, the termite mounds are gigantic structures compared to the size of these insects. But they collectively build it very, very intelligent behavior. And we show how challenging this is theoretically, that I'm not going to go into details today. But for those of you who are interested, this is something called POMDP, or partially observable Markov random process. Markov decision process, which is a very, very difficult theoretical problem to be tackled. So we try to investigate this problem with different variations, different versions of it. We work on mobile 3D printing. So here, typically the 3D printers that you might have used in your club was these kind of like desktop scale 3D printers. We call these kind of 3D printers as gantry based. But gantry based 3D printer cannot print structure larger than the printer itself. The only hope is to move the printer onto mobile robots and let these mobile robots print structures that can go bigger than themselves. And here we're showing a early demo of that, where these two mobile 3D printers are collectively printing some kind of structure that we designed, and this structure is as long as about 1 meter, and which is actually not possible to be printed. And we're printing 3D. We're just showing it on 2D. And this kind of thing is hard to be printed because of the size is too big, as compared to so in your regular desktop 3D printer cannot do. We also work on this kind of autonomous grading robots that we hope one day will empower our robots that will be sent by NASA to Mars and moons to build bases for us, right? So here is something we're doing there. And just last week, our group released this work called Ego Push, which is called learning end-to-end egocentric multi-object rearrangement for mobile robots. So given such a scenario, and this robot can only access a egocentric camera, like an onboard camera. From this kind of onboard camera view, the robot needs to autonomously rearrange the structures in this environment to form certain shape. And there's no GPS, no anything else. All the robot has is this camera view. So that's very challenging, actually. And you can search for this paper and the project website, and we give you a Unity demo to try to tackle this yourself, right? You can try to control this robot yourself, and you will see how challenging this task is. And we showed some effort using reinforcement learning, deep reinforcement learning, to do this in both simulation and in real world. Okay. Besides making, the last piece of the puzzle is about multi-agent collaboration, or what I call as mingling. So these robots, these agents, when we have more and more in the environment, they need to mingle with each other, right? They need to share what they know with each other in order to make the whole system safer, fundamentally. Think about a self-driving car. It can only sense so much. It can only sense so far from itself. If its view is blocked by nearby trucks or other big structures, so there's no hope that these cars can see through objects. And if you cannot see through, and if there is some bicyclist, right, coming towards your direction, and that may lead to some tragedy. So if these cars can talk to each other, then this kind of safety of the system can be fundamentally improved. And we did this both in simulation and in real world. This is a self-driving car company that we collaborate with. They run their robo-taxi service in multiple cities in the US, and we get their data, and this data is released open source. You can find this data set on my lab's website, and that shows this kind of multi-agent collaborative. This data set can help you to investigate those problems. And this multi-agent collaboration is also inspired by nature. In nature, we see different kind of animals, like here monkeys, right? They talk to each other to remind their neighbors different kinds of information, such as food, such as danger, right? So eventually, we think our robots and self-driving cars needs to have similar capabilities. So my lab students also have achieved a lot of great things. Some of them got really prestigious scholarships. For example, here, this student went to Oxford and got this Rhodes Scholarship a couple of years ago. My PhD student also got NVIDIA Graduate Fellowship. And our students are not only satisfied with their academic achievements, they work with industry closely, or if some of them even start their own companies. Building diagnostic robotics is a current startup located in the Brooklyn Navy Yard area, the New Lab, if you know where that is. And if you're interested, actually, you can reach out to them. They may be hiring like interns, right? You may get some research experience or industry experience with them as well, very easily, hopefully. So with that, I think I can stop here. I don't know uh, how much time I have.
You have ton of time. Keep going.
No, actually, I finished almost the content that I want to talk about. The remaining slides is really more detailed directions like construction robotics. So I want to see maybe there are some questions regarding the previous slides that I presented. If no more questions, I think we can, yeah, if there is interest, I can talk more. But then I think maybe we should open up for some discussion instead of just lecturing.
Okay,
I want
we
to
have some
see.
questions. So,
Mhm.
Andrew, what's your question?
So you mentioned before about how like mapping you can use videos. So I was wondering like is there like for the video, is there like a certain quality the video has to be in order to like create the best result? And also, is there like a specific type of mapping that is considered the best?
Right, that's a good question. So, you usually you need higher resolution videos. If the video resolution is too low, then you miss details, right? Especially if you want to tell where is the edge, like the sidewalk, the intersection between the sidewalk and the road surface. And if your resolution is too low, then you may be less accurate, right? And so, but then the resolution is not the higher the better. If it's too high, then the processing time will increase, and you want a real-time performance on the car. This kind of solution, by the way, the camera-based mapping solution is adopted by Tesla. So the Tesla FSD generates these kind of outputs as their map. So this is called occupancy map. The whole environment surrounding the car is represented by a grid of voxels, 3D voxels. Voxel is like pixel, but it's in 3D. And each voxel is labeled as occupied or not occupied. If it is occupied, it is further labeled as the semantic category. So as here, the color code means different semantic category. You can easily identify the cars versus the road surface versus sidewalk and pedestrian and things like that, right? I hope that answered your question.
Yeah, it did. Thank you.
Mhm.
Okay.
There was another
I
question.
think Rowan also had a question, so I'm gonna ask him.
My question was, you just described like many interesting technologies, and I'm wondering, what was your favorite project you worked on that applied these technologies, or the favorite one that you used?
I have too many. I like all those projects. They were all like my child. But I would say recently my attention was definitely more occupied by this Ego Push project because it's both a theoretically challenging task and also in real world it has a lot of implications. Again, I mentioned that my oh, actually I didn't mention, but my biggest academic dream is to to have our algorithms enable robots that work on Mars and moons to build structures. And imagine the challenge of doing those tasks in those extreme environments. The first thing is you don't have GPS anymore. When you don't have GPS, the robot has to localize themselves, but then you have to change that environment. So how do you localize yourself in a changing environment? And that environment is changed by yourself, right? This is a very interesting task that is coupled with a lot of challenges. And we're able to make some progress towards the direction. It's not perfect, but it is something, even this kind of capability was not achieved before. And this task has been studied for years, and we recently make some good progress. So I'm very happy with this work.
I love it. Thank you so much.
Thank you. Do we have any more questions before we open up to some more discussion?
Yeah, I have a question. So, um, with regards to like different technologies that you use in your robots, I have a question on like, or have you been or are you planning on using like RF or like radio frequency technologies for like navigation instead of just like LiDAR and other stuff?
Right. So people use radar in indoor environments, mainly for uh, pedestrian tracking. Robots tracking with less. People are focusing more on visual sensors like cameras or lidars. There are several reasons. First of all, the radar sensors was less accessible as compared to cameras and lidars, and secondly, the radar sensors is actually less accurate when it comes to localization accuracy. Because of those, I would say the localization technology is dominated by camera-based solutions or lidar-based solutions nowadays. But there are definitely people using uh, like a radio frequency like RFID or other kind of like people study like Wi-Fi based like wireless signals. But they're just yeah not as accurate and not necessarily easier than the camera or lidar based one.
Hi, Professor Feng. This is Wei Hua. I'm not one of the students. I'm a parent.
Okay.
I'm not technology savvy, but I feel this is a really interesting topic. And from what the slides you've covered, I actually had a few questions. One, since you just mentioned LiDAR, and then I remember reading a news article recently about Waymo using that technology, right? And then somehow one of the Waymo cars malfunctioned in San Francisco, and then it was not able to avoid a deer cat, like a cat that's been considered the resident or the queen of the neighborhood, and that poor cat was killed.
Right.
And so looks like lidar technology isn't as perfect as it should be, or and there's also another news article that I read recently about a local American vacuum robot maker who went bankrupt.
iRobot.
It was sort of bought off by a Chinese. It's one of the Chinese vendors supplying it with the key components, and then it was sort of it seems to me a layperson that one of the reasons it went bankrupt was because it didn't apply the latest lidar technology because of privacy concerns whatsoever. And so, do you think lidar would still be the direction to go, and how, or is there how would it be improved to sort of take a step further?
I see. Well, thanks for the question. You are actually this is very technical question. So
I just find the articles very interesting.
Right. So basically, I would say first regarding the usage of different type of sensors on robotics and self-driving technology is there has been always this debate on what kind of sensor you use. I think in the end, the answer is never a single type of sensor. Even Tesla use other sensors like radar, right? They use camera and radar, and Tesla has been arguing for not using lidar, and but they cannot just rely on camera. And similarly, Waymo car is not using LiDAR only. They also have camera and they have other kind of sensors. So I've been asked by some investors before, like 2 years ago, to make some prediction, and I think my prediction stays the same even nowadays. Is in the future, that you will see a mix of many things, just like what happens now, right? So you have Waymo cars driving on the road and have Tesla. Some of the higher end cars, self-driving cars, will be equipped with more expensive sensors like LiDAR. And then you have a bunch of other lower end cars that are equipped with less expensive sensors, or like only camera. But then they have different kind of like safety implications. And by the way, the accident is never only caused by only one type of sensor.
Okay.
Even Tesla, they crashed the cars many times with FSD. And I remember a couple of years ago, they have this very famous accident that the car hit on a highway, that because using only camera, the truck on the highway looks like a sky somehow, because
Oh,
the back of the car was reflective, and the car didn't detect the truck, and then the radar somehow was malfunctioning, and then the tragedy
oh
happened.
no.
Right. So basically, I think in the end, there's always this discussion about safety, like regarding safety. What kind of error rate can we tolerate? Do we need is 99%, like 99% enough, or 99.999 is enough? That I think that debate will never end. Um, it's not a new thing to self-driving. As long as we're still using technology, there's always going to have this kind of debate. Now, coming back to your question regarding your example regarding the iRobot company that went bankrupt, I think that event is not because they didn't use LiDAR or whether they use LiDAR. I think it's just the supply chain here in the US is just not as good. And the manufacturing capability was somehow over the years, like they systematically move this capability out overseas, right? And I think we all read this on paper. So I think it's not about a certain type of technology.
Okay.
Like it's not about whether they use LiDAR. I think it's that is just simply irrelevant to me, because
Okay.
there are many vacuum robots that use LiDAR. And then there are also many vacuum robots that doesn't use LiDAR. They use camera only. And like the reference to privacy concerns is also, I think some people don't care about it at all, right? So I don't think those are the major factors. I think the main thing is the supply chain, and also the I think it's just, yeah, I would say supply chain is the major thing, right? And then the labor cost and everything. And then that company itself, a couple of years ago, I had to deal with them because we purchased some robots from them, and their customer service was terrible, right? So I already predicted their fall, like since last. I told them I'm never going to
Oh
buy their product anymore.
no.
So there are like a lot of the times people see something happen and they think the 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 thing that was discussed most frequently at that period, people easily attribute those events to those factors, but really it's something happened in the more bottom level, and the roots can go back long in history. Uh, yeah, that would be my comment. But
Great. Wow.
I admit I'm not a business expert, so.
No, that's a very comprehensive all around answer. Thank you.
Mhm.
Okay, do we have any more? Okay, we have more questions. Okay.
I also wanted to add on about like the safety questions. So you mentioned before, like when you were mentioning the lab at the Tandon campus, I believe,
Mhm.
you said you guys study human robot interactions.
Mhm.
So when you are testing out, like when you're testing out like a new robot or whatever, um, are there like any restrictions you place on the robot beforehand to like prioritize the safety when a human is interacting with it, or like what restrictions do you usually put on like, a robot during testing?
Yeah, that's a very good question. So typically the robots we work, like my lab works, do not directly interact with humans. For self-driving cars, we unfortunately just don't have the capability to have a self-driving car at the NYU. I cannot pay for the parking. Um, that's a joke. But when we ever need to have our robots interact with humans, we have to go through a standard procedure called IRB. I think it's called Institutional Review Board, kind of things like that. Uh, People like the third party needs to review the protocol and make sure no human or any form of life will get like hurt, right? Especially humans will not be hurt during those experiments. And typically, those IRB reviews are required for medical robot experiments, assistive technology experiments. We just work on robot arms, and when we work on those algorithms, humans are standing away from those robots, and there's no typically very very low chance for our students getting hurt. Therefore, we don't need. Usually, our experiments are exempted from the required IRB reviews. But if your interest is about this kind of, for example, the exoskeleton robots, right? When you build this kind of exoskeleton robots and you want to wear it to do tests, you actually have to go through an IRB review to make sure you're not getting hurt, or maybe your volunteers will not get hurt. I hope that answers your question.
Yeah, it did. Thank you.
Okay, do we have any more questions? Okay, I think my mom has another question.
I would like to follow up on Dr. Feng's comment about the supply chain issue, which was just sort of exposed to the maximum during the COVID pandemic, and now with the political scene. Could I mean, I'm not going.
Is this still recorded?
Politicize anything.
Maybe we should stop recording for the remaining.
Oh no, I'm not going to name anybody or name any country or it's just I feel maybe it's not I just feel that here like do you interact with the scientists or engineers like in other countries, and how do you feel that their research or their work compared to yours? It sort of has a little aspect of connection to the supply chain, but I want to make sure that it sort of in the scientific or research collaborations, you must sort of interact with all the other upstream, downstream, scientists or engineering teams. How do you feel like collaborating with them? Is somebody way ahead of you, some country or some part where you, or how you learn, or how does that change?
Yeah,
work?
I got your question. So basically you're asking the scientific collaboration environment in the current geopolitical environment concerns. So first of all, science is never a single field. So it's hard to say. I would say you can never say probably which country is ahead of which country overall in terms of science or engineering, because there are so many different fields. For example, the AI algorithm side, US is still like undoubtedly number one in terms of the AI research, right? Although other countries are there are strong competitors in both Asia and Europe, right? But then there are other fields that Asian researchers or European researchers are way ahead. For example, the power technology, like in terms of transmitting powers across, like electricity across long distance. This is undoubtedly the Chinese engineers and Chinese scientists are way better
Wow.
than US or European countries, right? So just because they have the need and they have to do it, right? So then there are, you can easily make other examples where there is always some country that is better than all other countries in certain fields. So it's a very complex landscape. Um, uh, Overall, I would say still US is leading in many areas as compared to like other countries, other continents. Um, However, other countries are chasing after US, right? They're growing their spendings and in certain areas, for example, related to our talk today, robotics. Many of you here, I can see, probably are Chinese Americans, and you might have seen the CCTV's Spring Festival Gala that features many different robotics technology. Very amazing, right? So those are the things that they are catching up, and they're catching up very fast. It's hard to say that which one is leading, in fact, because US is good in software in algorithm, but we're not so good at the hardwares. The products, like the products we use, and many US universities are using, are actually coming from China. Like these robots at a very low cost, they're made from China as compared to like in the US, there are good robotics companies like Boston Dynamics. They're really good, they're really amazing, but they're very expensive. As researchers, we just can't afford to buy those robots to do. Just give you some number, right? A couple of years ago, Boston Dynamics reached out to us and asked us whether we're interested to buy their robots. That's the first time they were willing to actually sell them to external users. And one of their quadruped cost about 70K. I believe like one of those cost about 70K, and that was already like I would say 5 years ago. And then just 1 or 2 years after that, I got quote from Unitree for their quadruped robot. Not as good as Boston Dynamics for sure, but it's only 10K, right, per unit. And they're becoming cheaper. Yeah, they're becoming cheaper now.
DJI,
yeah.
It's the same. It produces the highest quality, the lowest price.
Yeah,
and it's been banned.
Right. Yeah. Well, I cannot comment on those things, but the thing is, yeah, coming back to your question is like it's hard to say which one country is leading over all the fields. And this, I don't know whether I should say a sad truth is the current geopolitical environment is forcing very talented people to leave this country. And that I know for a fact, right? I have many friends who are like me, and they were here on student visa, and they cannot get their visa continued after they got their PhD or postdoc, and they were forced to go back to their home country.
Oh my gosh.
This is not limited to one country. It's not just China, not just
India.
India also got this, right? And many other countries as well, including Europe.
Oh.
Very talented like European students, right? So this is just I think people in this citizens in this country needs to think what kind of future they want. I think I chat with many of our friends in the scientific community and engineering community that we all believe the biggest strengths of US is because US was able to attract many talents, and
Absolutely.
many of those talents are coming from overseas countries.
Yes.
They were not born here, but because of geopolitical reasons, and it's just very unfortunate, right? And
Yeah.
it's actually not very costly because US are paying to educate those researchers and then forcing them to leave. It's just right. It doesn't make any sense. But yeah, well, that goes beyond scientist control, and I really am not expert in that. I cannot comment. I'm only talking about my observation.
Oh, I really do appreciate. Yeah, I didn't know though. Yet some of your friends or PhD students, those highly talented people, oh my God, they can't get their visas renewed. That's really sad. I didn't know this. I mean, oh gosh, why?
There are so many cases. Even just my student, I have a PhD student whose visa got rejected, and
Oh my gosh.
he was supposed to be able to get a faculty position in the US and teach for America, but looks like America doesn't want him, and he has to go back.
That's a repeat story. The repeat God, of history, repeat of history of Li Zhengdao. That was like how many years ago? Same thing. Oh my gosh.
Okay, this is really
good.
interesting discussion, but I also have some questions that are more relevant to embodied spatial intelligence. And I think that would be more interest or more beneficial or relevant to the attendees. So do you have any like last questions before I ask my questions? Okay, no questions. Okay. So Professor Feng, what undergraduate or graduate degrees would you recommend for students to consider if they are interested in your field of interest?
So I wouldn't recommend any degree, actually. I would say because in my view, in the future, of course, maybe not as soon as when you guys went to go to college, but eventually I think college degree will be a single or just like one or two major or three major degrees, and everything else, for example, engineering, I think it should be probably just one or two engineering degrees, especially with the presence of AI. So I would say at this point, picking any degree doesn't really matter that much. What really matters is what do you learn yourself? What kind of skill do you grow? What kind of work do you get involved in your undergrad years? Um, uh, I think roughly, right? If you're interested in the health sector, right? Maybe you're more interested in the chemistry and bio-related directions. That's more of your focus. If then you're more interested in the like AI robotics side, probably especially robotics, right? Mechanical engineering, civil engineering, computer science. These are very related to robotics and embodied AI. And again, it's not just one single major that does them all. The computer science students, unfortunately, don't learn that much in terms of physics and engineering skills, but embodied AI, as the name suggests, it needs to be embodied. So you need to put everything in an embodiment, some kind of physical form. And engineering students historically learns less about or stress less about their computational skills, although this is changing now, right? But then for embodied AI, you have to do AI. You have to be able to code a computer. But then with the AI now, this is also changing because even computer science students having difficulty finding jobs last year. So it's hard to say, right? The future is complex. The dynamics hard to predict. I think the only thing that I'm certain is the major will matter less and less. What's important is what kind of skill do you immerse yourself with? What kind of skill do you develop? What kind of experience do you get? If you're just following the traditional path, then it will take you longer to get where you want to be. But if you're willing to embrace the uncertainty and go out of the traditional path, then I think there will be more like diversity in the ways that you will be successful.
Okay, thank you.
Mhm.
Okay, so Lucas has a question that he put in the chat. He's asking, in terms of robot mingling, how would you go more in depth as to how robots communicate with each other? And he's also asking, do they map area collaboratively? Also, what particular challenges are currently faced with this? Example, contradicting data from one robot and another. Or he's saying, I've seen something like Waymo blockages where multiple autonomous cars are stuck in
Right.
traffic caused by each other.
Right. I think that's a good question. So I don't think I will have time to go into the technical depths. You can check some of my work called I'll type in the chat box actually V2X theme. Yeah, you can start from this paper and then you will see. So basically, one of the challenge is indeed about how do you balance the amount of information you send versus the actual information people need in your neighboring cars. How do you send those information in the most effective and efficient way so that you don't block the whole communication channel, but your neighboring cars get what they need to perceive the things that they could not have perceived without this communication, right? So mapping collaboratively, that's one thing, right? That's also one good example of robots mingling each other. They collectively explore the environment and build a map like ants. And people have studied this in the robotics community as well. The challenge is about again how to communicate. How do you communicate with each other, and how do you make sure the communication stays within a consistent sort of like framework, coordinate framework when each agent are traversing in this environment, and they get their position orientation changes from time to time. How can they communicate this to their neighbors? And all these are challenges, right? And the Waymo issue you mentioned is about related to game theory. People try to use game theory to tackle this. Also, people are using just deep learning and data-driven methods to solve it. That's about multi-robot coordination. When you have multiple robots operating in nearby regions, they need to coordinate. Otherwise, they will block each other's ways, and that will create deadlocks. Okay, so yeah, my answer will be a little bit superficial because I don't have time to go into the details, and you probably don't have the background for me to go into those details for. But this is a great area to get into. And there are many open source resource. And again, I think the good and the bad and good thing for your generation is that you have AI, and you can learn so much faster, so with so much breadth, more easily as compared to before. So use this well, and use it wisely. I think your generation will be able to do so much more than what previous people can do.
Okay, thank you so much. Okay, other question from me. So recently, there have been many tragedies in commercial aviation involving ATC, such as mid-air collision near Washington, D.C. So ATC officers' jobs are very complex, and small mistakes can cause like really serious issues. Do you think visual learning LLMs and automation may be able to assist them in their job?
Right. First of all, I'm not expert in aviation. My comment will be based on
Yeah,
my
just like how do you think it can relate?
yeah, I think definitely it will help, right? Because again, the challenge is I would make an analogy between that versus the self-driving car or delivery car. So the delivery bots right now that are running so-called autonomously on the street are not so much autonomous because they have to be monitored by someone who sits behind their monitor, right? Because they need to handle situations that these robots cannot handle autonomously, blocking each other being one of them, and there are other things, right? So, and the thing is, these cars and their human monitors are not one-to-one mapping. It's not like one person is responsible for only one robot or one car. Actually, one person is going to monitor multiple, right? Why can they do that? Is because of AI, because of deep learning. And with those, we have the so-called autonomous detection of anomalies. Any anomaly event in the system is monitored and then reported back to humans. So one person's attention bandwidth can span across multiple vehicles to handle these situations. So I would say similar thing could be applied to the field of aviation management and monitoring. I would assume people are already trying this, startups, ideas, or right. So yeah, but again, I'm not an expert in that field itself, so I wouldn't be able to comment too much more than this.
Okay, thank you for that answer. It's very, very interesting. Okay, so one more. Robotics have advanced a lot in the past few years. So right, so especially humanoid robotics. If you watch like the Spring Gal, it's really incredible how between 2025 and 2026, humanoid robotics, like especially in China, have advanced so much. It's like night and day. So how do you think embodied spatial intelligence can change the way robotics, and especially humanoid robotics, are used in the future?
Yeah, so if your question is very, very big and broad. I would say the field of robotics doesn't get invented overnight. Roboticists, there are roboticists, there are multiple generations of roboticists, right? So this field has been studied for over several decades. And why is embodied AI and robotics become so hot recently is because the advancement of AI and because robotics needs to be intelligent before they can be really useful. Otherwise, they can only do repetitive pre-programmed stuff. Without intelligence, they cannot handle any like uncertainties or any unexpected situations. And those will be like greatly limit their potential. And AI allows us to like at least gives us hope and potential to tackle this direction. And therefore, yeah, that's basically the overall answer to your question. And more specific to humanoid robots, there are still a lot of technical challenges in humanoid robotics field. From the hardware perspective, we're not seeing a good robot hand yet. A robot hand that has all kinds of sensor mechanism like tactile sensing, temperature sensing at high resolution with high frequency, low delay, just the hand, right? This is just the hand. And then the form factor of humanoid robot is not finalized. Some people are thinking you have to use legged robot. Some people think you don't have to use leg. You can use wheel only robot with one or multiple arms. And they both have their points. So these are the hardware side of the challenges. But then the software side of the challenge is most related to the AI aspect that you are asking. We still cannot control the full body motion of humanoid robot that robustly. That's why you constantly see on social media all kinds of sort of like a failing videos of Unitree or all kinds of humanoid robot, right? They at some point they fail and they make some funny or maybe dangerous actions. So those things needs to be addressed by advancing embodied intelligence. And AI has to work together with hardware, and AI has to be embedded in hardware. in order to address those challenges. Therefore, yeah, so basically there are so many things, right? This is just one, the locomotion, the manipulation, the whole body control, and then there are high level that's tasks that's what my group is focusing on. For example, humanoid robot still cannot walk from NYU to Columbia that you all can do, right? You can either walk along the sidewalk or you can take a subway. But the humanoid robot cannot do this, right? It's even difficult for humanoid robot to go down to the subway station, go through the turnstile, and find the right train to hop on. So all these are challenges, right? From low level motion control to high level task planning. Yeah, and all these I cannot imagine them being solved without fundamental advancements in AI and embodied AI. So I hope that answers your question.
Yeah, great. To add on to that, at your lab, have you ever like encountered like roadblocks in computing power? Because AI algorithms are getting more and more demanding, basically like constantly.
Yes. Yeah. Well, we actually before this talk, a student was asking me where do I get 4 more GPUs to finish my experiments, and next week is our paper deadline. Right? So we are constantly facing this kind of challenge every day. As a lab director and center director, a big portion of my job is to get funding and get donations, get gifts from all my connections, so that we can do the research we want to do. And the hope is one day my student becomes super rich and they can donate back to my lab. Yeah, that's joking. But NYU is actually doing pretty well as compared to other schools. NYU invest heavily in this kind of compute. We actually get some free GPU compute at NYU, but of course it's nothing compared to OpenAI and NVIDIA can have access to, right? This is the ongoing discussion, and it's a challenge that remained for multiple years since I would say like 10 years ago when
Okay.
the boost
Yeah.
of AI is already there.
Thank
So,
you. Yeah.
yeah.
Okay. Do we have any more questions from the attendees? Okay. Okay, so it's been over an hour. Thank you so much, Professor Feng. I think this is a good ending point for today's talk. Thank you so much for sharing your insight. I'm sure we all learned a lot about embodied spatial intelligence and what the AI Force Lab does. Yeah, you guys should check the chat because both I and Professor Feng have sent links to the resources that he works with. I think I tried out the Ego Push demo on Unity. It's it's actually really hard. I thought it'd be pretty easy, but it is extremely hard.
Yeah.
So yeah, check that out. I'll resend the link. And yeah, that's basically it. Thank you so much, guys, for coming today. And I hope we can have more opportunities like this in the future. Okay.
Sure. Thank you
All
for
right.
inviting me. Yeah.
Yep. All right. Bye-bye, guys.
Bye, guys.